Okay, we're at a customer's house today, and she had called me to do a preventative maintenance checkup on her system. This house is about, well, it is a 2006, so the system isn't that old. So more than likely everything's going to be okay with it, and we'll get started. We're going over the breaker panel. Gotta move her trash can here real quick. Okay, and check all the connections in there, make sure everything's tight. Make sure there is no obvious signs of wear. Okay, now this is your air conditioning breaker here, and it's a 2-pole 40 amp breaker. Okay, and basically what I'm going to do here is just inspect, make sure there is no obvious signs of wear, like I said, and just tighten all the connections as best as I can. All these are pretty tight. I don't think we're going to have many issues. Okay, everything seems to be okay. Again, just want to make sure everything is sound. There are no burnt wires, any charred connections, or anything like that. So that this can be put back together, and we'll go on to the next step. Now, a lot of people, they don't understand what sometimes a tripped breaker is. Give me a second and I will kind of explain. Okay, now if you want to step over here, this is your breaker in the on position. Okay? Basically what happens is when it's off, it will be off. When it is on, it will be on. Okay, tripped is somewhere towards the middle right. Sometimes you'll have a little see-through panel here that will be red. That also means that it is tripped. Or these right here, test reset buttons. Those are tripped as well. That means that it's tripped, obviously. So there's a little bit of information as far as that goes. Okay. So what we'll do is we'll go pull the disconnect out of the condenser. And there's our dog. Okay. Now, this is a non-fused disconnect. It isn't really what I recommend, but they do work. Like I said, we'll go inside now and make sure that the thermostat connections and the thermostat are okay. And I left my screwdriver on the kitchen counter. Okay, the system's off right now. It's not off, but it's just not calling. Basically what I'm going to do is I'm going to switch it to the off position right now and pull the base off and make sure that all these electrical connections, low voltage connections, are all tight. Okay, sometimes they can work their way loose and cause shorts, and then your transformer will have to be replaced or refuse. So we'll tighten these up here. Okay, all that is tight. So we'll go ahead and put this back on here. Okay, switch it over to the cooling position. And then go down in temperature. And we'll go out and check the condenser. So what I usually start off doing is I will pull the housing off here, the condenser fan motor, and check for bearing play. Okay. And again, it is a newer home, a newer style unit, so the likelihood of us finding anything wrong with it, besides the little minor things here and there, are not very good. Okay, so after that is confirmed that there is no bearing play, we'll put everything back together. And then what you want to do is make sure that nothing is in the way of your fan blade. The last thing you want is to start up the system and blow the charge through the fan blade hitting your copper lines. Like I said, this is a newer style home. It is a airflow Lennox 4-ton heat pump. Basically what we want to do here is just go over all the electrical connections, test the capacitor, look at the contactor, make sure there are no signs of pitting. Again, this overall looks to be in okay shape. There are no obvious signs of any wear. Now what I'm going to do is I'm just going to pull the connections off the capacitor and test it in there. Okay, so by the way, this isn't the proper way of doing it. You want a bleed resistor of some sort, but make sure that the power is off to your unit, and with an insulated handled screwdriver or pliers of some sort, you can ground out across the terminals. Again, you want some kind of bleed resistor to do it the proper way. Okay, now this is a 60 by 5 dual run capacitor. Okay. And we will test out the fan side. And we've got 5 exactly, so that is good. Okay, now we'll test out the capacitor side, or the compressor side, sorry. And that too is okay. So, go ahead and put everything back together. Okay, again, all the electrical connections are all tight. Get an inspection overall of all the electrical components in the system. Everything looks good. Okay. Now, what we want to do is go upstairs into the attic. Our air handler is in the attic on this house. So we will go up into the attic and test out the connections, capacitors, and make sure all the connections are also tight as well as the disconnect. Okay, now one really important aspect is to make sure that the filter is clean. You want to change it once a month, okay? This one needs to be changed. It's not the cleanest, it's not the dirtiest. You can still see it through it, but it needs to be changed. So I will have the homeowner try to find me a filter so I can install it back in place. And we also supply filters at an extra charge. Usually the homeowner does have a spare. Okay, now all of you that do live in Arizona, in the Santan area, know that it is about 105 degrees out today, so it's going to be a little hot up here. So pardon my sweat. Okay, at this point, what I do is I just do an overall inspection of everything before I actually get into the inside components of the system. What I usually do, and I'm not going to do it today because of recording video purposes, try to keep it as short as possible, but I would usually cut these lines, put water in there, and then flush it out with nitrogen. That basically ensures me that every bit of debris that is stuck in the secondary and primary lines will be completely flushed out. And I do an overall inspection of ductwork. The ductwork here, like I said, it's a newer home, so all the ductwork seems to be intact and in good shape. There is no obvious leaks of any sort anywhere. Okay. Both supply and return are okay. So now what we'll do is we'll take out this 60 amp. Well, it's not really considered a 60 amp, but it is rated for 60 amp, and it is a non-fused disconnect. The same disconnect as out at the condenser. And we will make sure all electrical connections inside are tight. Okay, after ensuring that all connections are tight, we'll go ahead and put the disconnect back together. And take off the panel. Okay, now the previous technician has put foil tape all around there due to airflow or air leakage issues. So we'll check the bearing play on the motor, make sure it is tight. Okay, and then on some of these units, the capacitors are inside the panel itself, where all the connections and different components are, and then some of them they make it a little bit of a pain to get to. This one is one of those pains. The capacitor is all the way back there, so bear with me and we will check this capacitor. The capacitor itself is a 7.5 microfarad, and we will check it. Okay, and that's 7.49. So this capacitor is still okay. Alright, now next step is I just kind of want to go over the overall condition of this electrical panel in here. It's got backup heat strips. During the winter months, what will happen is when the system goes into a defrost, and this again is a heat pump, these backup heat strips will come on and prevent that cold chill in the air when it is in the defrost mode. So all this looks really good. I'm just going to go over it real quick. And it looks like they had previously put electrical tape on all these connections. Because my guess is they had insulation issues touching it. And on these airflow Lennox style Aspen all style air handlers, they have these connections here, the high voltage, really close to the panel itself. So you got to be careful when you're taking the panel on and off as not to trip or blow something up. Okay. So overall, everything looks very well. The heat sequencer looks to be in good condition. The heat strips themselves look to be in okay condition. And again, we're not going to get too into detail. This is a summer startup evaluation. It's not a winter startup. If this was a winter startup evaluation, I would pull out the heat strips and check resistances and make sure that my heat strips is sound. Everything looks real good. I'm going to go ahead and put this panel in a way that when we go to start up, we can check our amp draws on our motor. Okay. So now I'm going to plug this back in. It'll come on. And basically what I want to do here is check the amp draw of the motor itself. This one is rated for 5.5 amps. So we will see what it is pulling. It's pulling right around 3.9, 3.8. 3.85 to 3.9 is what it is pulling, which is okay. So that's still in good shape. And again, just scoot all the wires back, make sure overall that there's going to be nothing that will come in contact with this panel as we put it back on. Of some sort. Know that the big track home guys out here didn't exactly take their times on some of these homes, so they don't exactly look the best. Okay, and I'm not going to name any names, but you know who you are. Overall, this system looks to be in okay shape. The amp draws, the bearing plays, all the electrical components are sound. Overall, ducts, both supply and return air, are in good shape. And again, just want to express, I would cut these lines, put water in them, and then flush it out with nitrogen. That ensures that we got all the debris out of the drain lines. Okay, let's head on downstairs. Tape measure, no big deal. Now again, I want to kind of inform you of the different aspects of what entails in a checkup, an actual inspection, and then there is a tune-up. Okay, usually the tune-ups include usually 1 to 2 pounds of Freon, condenser coil cleanings, things like that. Inspections are just overall, get all is doing. I do a system checkup, and then I inform the customer of what is acting up, if anything, in their system after all of it is done, and then they make the decision to either replace it or not. So again, it's just a system checkup. It is not a system tune-up by no means. The tune-up will come after the customer has authorized any repairs that I find. The only thing with system tune-ups are they're going to charge you, say, a $159.99 fee no matter what. So what I like to do is find out if the system is running okay, do my preliminary checks, and then inform you after of all the issues, like I said earlier. And here we'll just basically go over a few things. Right now, this is a piston style metering device in the indoor system. So what I will be focusing on is superheat readings. Okay, usually you want to do both. But today, because we're recording a video, we'll just do the superheat readings and make sure our pressures are okay as well. So we'll get started on that. And another thing I want to go over is every time I do a system checkout, it includes a coil cleaning. And then it does include a brief inspection of the indoor coil. Okay, sometimes you can't get to the indoor coil as easily, so you either have to A, pump down all the Freon into the condenser, then we have to cut the lines and pull it out and clean it, or B, we can pull off the return sometimes and get in and clean it that way. It just really all depends on what kind of system you have, application, is it in a closet, in an attic, those kind of things. So we'll go ahead and put on our gauges here. Outside. Now what I would usually do is plug in the disconnect and let it run for about 10 to 15 minutes. Let the pressures equalize, let my superheat readings stabilize as well. So I will plug this in. Usually let it run for about 10 to 15 minutes. But in this case, we're going to let it run for about, I would say, 2-3 minutes, let it stabilize, and then check it. Now what this is it's a temperature clamp. And this temperature clamp basically will tell me what temperature my suction line is. Your suction line is your line coming back from the air handler to the condenser. Okay, what you want to do is clear your spot, clear yourself a spot here. Get a good reading. sit for just a minute and stabilize. Okay, the next step would be to go ahead and pull this off here and check the anthros. Okay, now the anthros of the fan motor itself, and then the compressor. Okay. Good. And we're okay. We're okay on both. So. Now this is an R22 system, so during the hottest part of the day, you're probably looking anywhere from about 10 to 15 degrees of superheat. Give it a minute and we will know exactly what it is doing at that point. Got hot air coming out, which is always a good sign. My line coming back from the air handler is nice and cold. Those are some real quick checkouts if you're ever worried about your system. And right now, we seem to be having right around 12 to 15 degrees. We're actually sitting at about 13.5 degrees of superheat. So the system is running really well right now. There are a couple obvious things on the indoor unit and the outdoor unit that I'm going to point out to the customer. We will see about getting it repaired. Freon wise though, looks to be sound. We don't have any issues with that. We won't have to add nothing. A lot of technicians out there will take off their gauges, both hoses, and be done with it. Okay, the proper way of disconnecting your gauges from the AC system is to pull off the high side. Okay, and then open both sides. And now what it is doing is it is ultimately pulling back in through the suction line, taking the freon from your gauges and putting it back into the system. And in most cases, before I put back on the caps, is I will just kind of wet my finger a little bit, put it over the shraders, and that assures me that nothing is leaking out. And now we'll then put everything back together. We'll go inside real quick and we'll check the temperature splits between the return and the supply. Okay, now you usually want anywhere from an 18 to a 22 degree split. I usually always take the split directly at the unit, but in this case the duct runs are really short. It isn't really gonna hurt too much to do a split down in the home. Okay, so that is a little over 75. Come in here and we'll put it up to supply and see what she's kicking out. 70, 69, 68, right at 64 degrees, 54 degrees is what it is. It's staying right at that temperature. So that's a 20 to 21. Okay, you just seen me take temperature splits. Basically, it's 20 to 21 degrees. Okay, what you didn't see were the condenser coil cleanings and the condensate line flushes. Those are always included in my checkups. So if you have issues with any of your heating or cooling systems, you can give us a call, 480-352-8710. You can also reach us by email at jason@northernairaz.com. If you have any questions or anything, please feel free, give us a call. Thank you.